an introduction to statistics. Hi, I'm Dr. Tomo Bento, and what I'll be talking about is give you a brief introduction to the field of statistics. We'll look at statistics as both a field of study and a set of tools used by many other disciplines. And finally, we'll make the distinction between descriptive and inferential statistics. Why should you be required to take a statistics course? Well, the obvious one is you're required to, and many disciplines do this. And why do you think so? Well, one of the things I tell people is we're surrounded by data, whether it's voting behavior and public opinions, medical research that we read about all the time with new discoveries, the state of our economy and the employment or unemployment. Making sense of this data is often a challenge. Most disciplines and the research that takes place within those disciplines depends upon statistical techniques to make conclusions. That is the essence of why your particular major wants you to have some exposure to statistics. And it's especially true in the decade beginning in 2020. Collecting and storing data has become easier and cheaper than ever. We are in the era of big data, and I'll give you a definition of big data in just a little bit. Increasingly, we want to be able to use that data to help us make decisions. Companies, organizations, the government, researchers want to be able to use this to help make decisions. You might have heard the term data science. It's something that's emerged in the last 2 decades. And really, how is that different from statistics? Well, there's a lot of similarities. There is a connection between the two. In some ways, it's not really different. They're used interchangeably in some circles, and they use many of the same techniques. However, I think there are some important distinctions, and I'll make them briefly here for you. First, data science, it's less driven by formal hypotheses. The data is often collected for other purposes, and it's being used in a new way or a different way, and therefore it has to be managed and even mined. My sense of mining is we're kind of delving into it to explore and find things. And in many cases, prediction is the most important outcome. They're looking to predict a decision or a future event. Statistics, on the other hand, tends to be more purposeful and driven by formal hypotheses. So we will have to deal with that in a course like this. Data is often collected specifically to test a relationship or an idea. And then inference is a key driver as an outcome. We're going to make an estimate from a sample to a population. Now, just to be clear on big data, what is it that we mean? It's used a lot now and often is thrown about, I think, a little bit too casually. We'll learn about samples in this course, and we'll take a sample to represent a population of interest. A sample might be 30 observations, and we might have 10 variables. And here is a partial data set, a health set of data. It has, I'm not showing all the observations, but I have it for 30 people, and there are 10 variables there that we're looking at from their gender, their age, their height, their BMI, and so forth. Big data, on the other hand, it's often called high dimensional data. It can be long with lots of observations, or wide with lots of variables, or in fact both of those things. It might have millions of observations and hundreds or even thousands of variables. That is something different that has occurred only in the last 30 years, where we're able to store and collect that kind of data easily. And as it's become more available to us, people are interested in exploring it further And that's where data science has emerged. Two thoughts I want to share up front in this course, and they're a little provocative. The first is, just because you see something in your data doesn't mean it's so. And this will be really true when we're dealing with samples. So if I make an estimate, that doesn't mean it's a good estimate. We need some way to kind of understand or capture the idea that, how good is this estimate? And that'll be a reflection of the way we sampled and our sample size and some other factors. The second idea is that we're often data rich and model poor. By that I mean we tend to have a lot of data, but we don't always have good ways to make sense of it. So modeling that data is an art form, I think, and something that's become increasingly important. There's a book, The First Measured Century. I like it a lot. It's dated a little bit now, but I think it's still important to talk about. And they talk about the first measured century beginning in the 1900s. And it brought in this new era of collecting data. So we're collecting more data from that point on with more accuracy on more topics and making this data more available. And that's what's kind of unique today. And it's also very exciting. So let me give you one example from this. Americans work harder than they used to, so they have a lot of less time. What do you think? Is that true or not? So this is some of the information from the data. And in fact, no, we have more free time. And what this shows, as an example, is the change in the manufacturing work week over time from 1900 up to 2000. And what it involves is mechanization, the state of the economy, the labor and social movements. Labor unions brought in changes about the work week and paying overtime and other kinds of conditions that employers have to accept and recognize. We went from 10-hour days, 6 days a week, to now familiar 40-hour work week. And we are being challenged right now that maybe the 5-day work week isn't going to be the future. I know some companies are already exploring 4-day work weeks. So what is statistics? There's a lot of different definitions, and here's the one I like. Statistics is the science of data. It reflects every aspect of how we handle, manage, and use data. It can involve the collection of it, the classifying, summarizing, and organizing it, the analysis of it using summary measures and graphs, and then the interpretation of the results. And what's unique about statistics is both a field of study and a set of tools used by many other disciplines. Business economics, the social sciences, the health sciences, they're all using statistics to help them do research. We have to separate those two. In this course, we're going to use the discovery and ideas from the field of study, but we're not going to have to verify or prove them. We're going to take them at face value and use them as a set of tools. And this is a start for you to learn how those tools might be useful. We're going to focus on two types of statistical applications. The first is descriptive, and here's a plot of body mass index that really a histogram of it, and it shows a distribution of that for a data set. And then inferential. So for the very same thing, we might do something like a confidence interval. We'll make an estimate of the mean and put an upper and lower bound around that. We're going to learn how to do confidence intervals as part of this course. For descriptive statistics, it uses summary measures, graphs, and measures of association to help describe the data or relationships in the data. All statistics, at their heart, should be descriptive. That's important. It's not going to be useful unless it helps us describe the data. And that focus is on describing it with an emphasis on a term I'll call parsimony. And there's the definition. It's a principle of means of achieving something in a simpler and easier way. So we don't need to look at all the data points. We're going to use summary measures like the average or the mean. That's going to help us understand it. Look at the following data. And it's kind of large. You're not going to be able to read them, but there's a lot of different data points there. So what do you think this is? Well, it's my son's data use on the cell phone for 1 month. We ran into a problem, and we were having excessive downloads, and I wanted to figure out what was going on. So how might I look at it? I certainly can't look at all those individual data points. Now, I might have summary statistics, and this gives us ones that are based on position. It's called the quantiles. The median is the one you might have heard about as a positional measure, and that's 22,754, I think it's kilobytes in this case, of downloads. That was the middle. Or I might look at the summary statistics, which are usually based on the mean. So the mean's a little larger in this case, 28,658. That kind of gives me the average over that time period. I can also break down the data, say by day of the week, and I use Excel to help me do this, and a thing called a pivot table. So maybe this gives me insight. It looks like on the middle of the week he's using more data than other times, and certainly less than on the weekend. And I can also do it by a day in the billing cycle and see if there are some trends there as well. Graphing data can be really a powerful tool, and we have better means to do it than ever before. Excel is a really good, and it's going to be something accessible to all of us. So I am going to encourage you to use Excel in a course like this. Interesting enough, I get data on cremation rates. I just found it. I signed up for it, and they keep sending it to me now. I don't have a funeral parlor, but what's interesting is that now more than 50% of all burials are done with cremation, and that's a big change. But we also found that it varies a lot by state. So I use a software called Jump to make a map of the rates, and you can see that in the South they're lower, and way out west there, I think that's Utah. There must be something about the Mormon religion that doesn't like cremation, because those rates are lower. So this variable varies by state. I also went on and found NerdWallet does an annual assessment of average debt, and I was able to do that and then make a graph of it. And the debt that takes place on credit cards, auto loans, the student loans is the one that is really entered into the media a lot because it's gone up, and I'm sure some of you are familiar and sensitive to that and what that might mean for your future. Descriptive can be powerful tools to look at more than one variable, and there are some pretty sophisticated techniques. We won't deal with a lot of these, but I will introduce one, which is called regression. And in this course, there's only a brief introduction. But what I have here is the extent of sea ice for the North and South Poles by month over time. And you can see that they definitely vary. And then I did a thing called regression and modeled it and established that there was both trend and season as part of this data. Now, I know you don't fully understand everything that's there. I just want to point out that there's a lot of more sophisticated techniques down the road if you keep pursuing statistics, and they're going to help us do more complex modeling of our data. Now, the other side of this is inferential statistics, and this is concerned with making inferences from a sample to a population. Whenever we deal with a sample, we deal with estimates and uncertainty. Remember I said just because we see something doesn't mean it's so. Our estimate could be wrong. The sample statistic will rarely equal the actual population value. And generally, we don't actually know the population value. But we will expect that our sample gives us a reasonable estimate. Inference helps us place our estimates in a probability framework that allows us to make conclusions from the data. And then again, here's my point. Just because you see something doesn't mean it's so. We need to have a probability component to any time we make an estimate. Inferential statistics are a powerful research tool. It enables us to make statements about a large group from a much smaller sample. Maybe we're doing a survey of people about their attitudes or opinions. A designed experiment, such as a clinical trial where we test the effectiveness of a drug, or an observational study where we're making estimates of the extent of, say, deer population in a region. Based on the principles of inferential statistics, we can survey about 1,000 people and make statements about a population of 321 or 320 million people. So, this is a typical survey question that's asked: is the country headed in the right direction? And I actually have some data over time, and we'll take a deeper look at this. The real question was, in general, are you satisfied or dissatisfied with the way things are going in the United States? And I'm giving the percent that's satisfied. You can see that in earlier times it was actually much higher. In 2008, it really dipped. We had a pretty deep recession at that point, and things have gotten somewhat better since then. Let's take a look at this more closely. What do we got here? It's based on a telephone poll of 1,015 adult Americans conducted by an organization, Gallup. And Gallup tends to do things right. We can trust their approach to making an estimate. It's also an estimate made at a particular moment in time. And you can see from the graph, our estimates can change because of circumstances. And the margin of error given here is plus or minus 4%. We're going to learn MOE, margin of error. Here's my interpretation. The survey is designed to represent adult Americans in November of 2019. The estimate is the percent satisfied, and it's given as 35%. Because we're taking a sample, we have some error associated with our estimate. In this case, error doesn't mean we did something wrong. It's just that a sample will never fully equal the population value. Since the sample was taken randomly, we have a method to estimate the error of our estimate. In this case, we're reasonably sure, and the coefficient will be 95% sure, that the true percentage is within plus or minus 4 percentage points of that estimate. So that means for an interval, it would be somewhere between 31 and 39%. If I take a sample, I'm not going to get certainty. I'm always going to get some uncertainty, but something we could still have confidence in. Okay, what's this graph about? Well, this is the approval ratings for President Bush for when he first started in February 1st, 2001, up to when he finished or close to finishing July 25th, 2008. And it's a pretty interesting graph. We can see things that happened that changed that approval rating. That was 9/11. And the country reacted and rallied around our president. Over time it went down, but then there was a spike. That's when the Iraq War began. And wars are often a time that rallies the population again to their president. And right here was when Saddam Hussein was captured. So you see another little spike. But in general, what you see over time, and by the time President Bush finished, his ratings were fairly low. We see a downward trend over time. If we look at President Obama's ratings, they also reacted to things, but it wasn't quite as big there. The red line is actually a smooth line that I put on top, but we can see that it changed over time, but always hovered within a somewhere between 40 and 60%. But it does change over time, and he ended on a higher, more positive note. So in summary, statistics is the science of data. It is a discipline, but also an important set of tools to conduct research. We've also noted that all statistics should be descriptive in nature to help us summarize or describe our data, and sometimes we'll have inferential properties that help us make statements about a population from a sample. A significant portion of this course will be focused on the inferential part.